Hi, good day to everyone. I will be bringing to you, or we will be learning today about the interaction of electromagnetic waves such as light as it approaches media or objects. Now, as they approach, they will behave in a way. They will behave in such a way they will reflect the light, they will refract, or they will diffract the light. First, we will learn about about reflection. We know that light is known to behave in a very predictable manner. If a ray of light could be observed approaching and reflecting off a flat mirror, then the behavior of the light as it reflects would follow a predictable law known as the law of reflection. Okay, I will illustrate it today how this ray as it approaches the mirror. Here is, for example, this is the mirror. This is the mirror. Now, when we have the ray of light approaches the mirror, we say this is the ray of light. Now, we call this ray of light as the incident ray. Incident ray. Okay? Now, this ray, as it approaches the mirror, it will be reflected. And this we call the reflected ray. We call this as reflected ray. Now, if we will draw a normal line along the mirror, like I will draw a dotted line, we call it a perpendicular line cutting through the mirror. Now, this line we call it a normal because this is perpendicular to the mirror. Now, the angle relative to the normal with the incident ray, we call it as angle of incidence. Or we represented it as the angle theta. Okay? Now, the reflected ray, the angle with relative to the normal, we call it as the angle of reflection. We call it also theta sub 1. So this is the angle of reflection. Now, with this, the formation of angle, according to the law of reflection, theta is equal to theta sub 1. So the angle of incidence is equal to the angle of reflection. Okay, we'll go to the topic of refraction. Now, I will show you a pencil submerged in water. What do you see? What is its appearance? Okay, you will see that the pencil seems to be distorted, right? It seems that the pencil is bended. The cause of this is what we call this property of light called refraction. Now, refraction causes the light to bend when it passes from one substance to another. So this is just bending of light from one substance to another. Okay? This is the bending of light as it passes from one substance to another. The term refraction is not exclusive to light. Refraction refers to bending or turning of any wave, such as light and sound, when it passes through a substance of differing density. Refraction does not occur when light passes from a blue color light to a blue color water, because both waters have the same densities. We must commonly see refraction occur when light passes between air, water, and glass. Why does light bend? Light only bends when it passes from one substance to another substance with a differing density. In our light, in air, light travels at about 186,000 miles per hour. So here is the speed of light as it passes through differing substances. So we see in air as 186,000 miles per second, water as 140 miles per second, and in glass 124,000 miles per second. So light travel faster in air than in water, and we call this property for water as to have a greater optical density. When light travels to air, it travels at around 186,000 miles. So as it travels to water, its travel becomes slower. So we will see this when the light is being refracted because of the bending of light.